All right, let's talk a little bit more about functions and function definition. As mentioned earlier in class today, a function is a correspondence between one group called the domain of the function and a second group called the range of the function, in which each member of the domain corresponds to one member of the range. We use this word correspondence here, but you could have just as easily done, instead of correspondence, used a relationship in there as another word. It's some sort of thing in there. And so sometimes we like to picture it. You've got a set of numbers called the domain and a set of numbers called the range. Oh boy, that is pretty slappy writing. Using a new pen here. Let me try that again. And so that's a little bit better. So we have things in the domain. Let's just put some numbers in here. And you've got some sort of relationship between those two. Like the 3 is tied with the 7, the 4 goes with the 8, and the 5 goes with the 11. That's a nice function that the 3 is only tied with one number in there. Another example of something that might be a function, if you've got your domain of 7, 9, 11 and a range of 2 and 4, you might have a function where the 7 maps or corresponds to the 2, the 9 corresponds to the 2, and the 11 corresponds to the 4. That's still okay as far as being a function. And so each input, each domain value is associated with one value that's in the output. And so let's do maybe something that's not a function, just to do something that's not a function. Here's the domain, here's the range, and if I have 3, 4, and 11 and 17. If I have the 3 associated with the 11 and the 17, then I'm not going to be a function because that domain is associated with 2 different values in the range. So that makes it not a function. It's that each value in the domain can only be associated with one value in the range in there. So, but it's okay to have, if you've got a domain where you've got, we've got one up here, where you've got 2 numbers in the domain mapping to the same value in the range, that's okay, because the 7 is only associated with the 2. If you start at the 9, you know exactly where you're going to end up. You're going to end up at the 2. But this one is a problem because if you start at the 3, you follow the arrow. Well, do you follow the arrow to the 11 or do you follow the 11 arrow to the 17? So that's not going to be a domain there because you've got those 2 possible outputs in there. You can even have everything go to the same number, 3, 4, 5, and just over here have 22. That's one of my friend's favorite numbers is 22, so I'm going to do 22 in there. But if 3 corresponds to 22 and 4 corresponds to 22 and 5 corresponds to 22, it's still a domain or still a function because 3 is only associated with one value. It's when you get in the problem with 3 associated with 2 different values that you run into problems. Okay. Now this is kind of messy to have these numbers just kind of drawn out in random things. So sometimes what we'll do is we'll have them associated instead of with a drawing like this. A lot of times we'll put our data into a table in there. Let me put in a table down here. So like this first function, we typically put the domain first in our table. So we could do 3, 7, 4, 8, 5, 11. And actually, let me go add another column. I probably can't do it at the top. We typically will have like X for the domain and Y for the range. and then you'll put in the 3 and the 7 and the 4 and the 8 and the 5 and the 11 might be another way to represent this same table. I'm going to move that up here. And can I make that font bigger? Whoops, not that. Home. There, I can change the font. Let's make it something like, well, 16 or 18 looks a little better there. So this table is the same as this drawing that I've done there. A little bit neater though. And I could actually make it even neater maybe. Can I put in bars in there? Anyway, that you've got a table there to organize those things, just to make it a little neater. You can have it arranged vertically like this one is, where you've got the domain is the first column and the range is typically the second column. You can also put in your table horizontally. So let me do, yeah, that one should work. Let's do something like that. Oh, where did I put that? I put that table inside of a table. Undo, my favorite friend. Undo. Okay, so let's go over here and let's insert a table. Something like this, roughly. And we'll make it bigger font. I mean, put in some values there. In the table, we generally put the domain on top and the range underneath that. If it's oriented horizontally, we'll enter it that way. So our second table function has 7, 9, and 11 in the domain, and in the range we've got, oops, I had an extra column that I don't need. That's okay. I've got 7 associated with the 2, the 9 associated with the 2, and the 11 associated with the 4. And let's make that bigger so you guys can see it. Let's make everything bigger there. Come here. Come here, table. Good table. All right, there. And then maybe I can get rid of that little line that's kind of thrown up in there too. There's my eraser. Please erase just the line. Yes. Okay. So the domain would be like 7, 9, and 11, and the range would be 2, 2, and 4 in there. So that's a nice function. You've got the 7 associated with just the 2, the 9 is associated with the 2, and the 4 is associated with an 11. Let's look at, make sure I'm not in that table. And we'll do one here for the one that's not going to be a function. Here. It ended up inside again. All right, let me go. There we are. Hopefully I'm out of there. Wrong menu again. Insert table. That's what I want to do. Insert a table. We'll do a vertical table where we've got X and Y again, and we had 3 associated with the 11 and 3 associated with the 17 and 4 associated with, well, I had it with nothing, but we can make it associated with something if you want to. We'll put a 12 in there or something. And I'll go back and fix this one. We'll add a 12 down here. And an arrow going from the 4 to the 12. All right, so but what you can do is quickly, if you want to see if something is function, check for repeats in the domain column. And if you have repeats in the domain column, make sure they correspond to the same thing in the Y column. So if I have 3, 11, 3, 17, 4, 12, that is not going to be a function because you've got the 3 associated with 2 different Y values in here. And that's going to be a problem. That's not a function in that case. You do have to be tricky though, because maybe sometimes they'll try and deceive you and maybe do, well, we'll put a 7 in here again. But as long as I do 7 again on the domain and I get the 2 out again as the range, I'm still a function. But if I got 7 and something other than 2, then I would no longer be a function in there. So look for that. Just do a quick check of the x values. If all the x values are different, you're fine. It's going to be a function. If you've got a repeat in the domain or the x values there, make sure that the y value is the same for those two values, that 7 is associated with the 2 in both cases. And that will make something a function. All right. I'm going to, how are we doing there time-wise? I think I'm going to stop here. And no, I'm just going to pause for a second. Okay, so I've copied those functions over to a new page. Because another thing that we can do, and something we're going to do in this course, is look at multiple representations of things. We're going to look at the same concept in a couple of different ways. And so we've looked at, with my little crude drawings, function definitions, we've turned those into a table, but we can also look at that representation because you've got x values and y values. You might think of that, well, that can look like a graph, is that I can graph these things on a set of axes, a coordinate system in there. So just kind of roughly sketching it out, I've got 3 big loud clicks every time I do that, huh? And then I'm going to count by 2s here. That's 2, 4. I wonder if this thing works better. 6, a little bit. 8, 10, maybe a little bit. 1, 2, 3, 4, 5. A little bit better there, maybe. I gotta writing with a big pen. It's sometimes hard to see around it. Ooh, erase everything. Okay. 3, 4. All right, so I've got 3, 7. So 3, 7 would be this point right in. Come on, draw 3, 7. Would be somewhere roughly in that spot. 4, 8 would be just a little bit higher. What are you doing? I got the wrong thing there. Okay. 4, 8 would be about this spot, and then 5, 11 is going to be up here somewhere. So we can convert these table of values into coordinate pairs, right? You can think of that as the point 3, 7, not just as 3 is x and 7 is y. We can look at those on that graph system in there. And we can graph our other one there. We've got 7 and 2. The second function, 7, 2, would be out here. 9 is 2, should be the same value. 11 should be 4, should be twice as tall. And then we come back and we draw another dot here at 7, 2 for that last point, but that's okay. So we're going to say that's 7. And this one here is 11. And we've got 2 on the y-axis there. All right, so that is a something that is a function. And then we'll graph this last one here that's not a function. Let me scroll down a little bit. Okay, this is the one that we had that was not 11, not a function. And on that one, we had the point 3 on the x-axis. That was where the problem was when we had 3 on the x-axis. Whoa, what happened there? Okay, I switched into different programs there all of a sudden. We had 3 on the x-axis, and we had both an 11 and a 17 on the y-axis there. All right, and so that one's the one that's not a problem. Every x value corresponds to something on the x-axis, and every y value would be, so every value in your domain is going to be a value on the x-axis. And what I've got is I've got 2 different y values associated with that one, 11 and 17. And those points line up vertically. And what that is it brings us to the vertical line test, that if you have a function represented graphically a function represented with a graph, a really easy way to tell whether or not it's a function is to use what we call the vertical line test. Do I have the vertical line test written down up here? Yep. And the vertical line test says that if it's possible to draw a vertical line that intersects the graph more than one point, then that graph is not the graph of a function. So if you have the graph of a function, you're going to intersect vertically at most one time. So if you look at this first graph here, every vertical line that you look at, there might be something over here that doesn't intersect at all. Whoa, that was a funky looking vertical line. But every vertical line either doesn't intersect, and that's okay. But if you do have a vertical line, it's only going to cross that function once. That if you go vertically, that's not quite vertical, but you are only getting one intersection there. Can I do the control click thing? Does that make vertical lines? No, that doesn't hold it vertical. But any vertical line that you draw is only going to intersect the graph once. So this thing here, this first one, is a function here. Every vertical line only intersects the graph once, so that's going to be a function. Let me change my font to something bigger here to make it easier to read for you. Okay, so yes, that is a function. This graph here gives us problems. If you look somewhere like x equals 2, it looks like there's 1, 2, go back to the draw thing, that I've got maybe when x equals 2, I've got a point in this area, there's a point in this area where it would intersect, and a point in that way. If you were to draw a vertical line through here, this graph, you're going to intersect 3 times at that point, so it's not a function. Over here, you don't have any problems. Vertical lines only intersect once. It's not a problem, but there is places here where you run into problems, and so this would not be a function in there. So this is not a function. Come on, let me type. What are you doing? It's showing up down there. I don't want you to show there. Not a function. It fails the vertical line test. That's not going to be a function. So quick, easy way. Graphically, you can look at it and say, oh, vertical line intersects more than once. It's not going to be a function. This last one, it looks like we're getting pretty steep right in here towards the beginning. Right here towards 0. Between 0 and 1, it's getting pretty steep. It's what we call an asymptote. It does keep moving closer and closer as you move closer and closer to the y-axis. This line gets closer and closer to the y. If you get a value closer and closer to 0, it does move closer to the y-axis, but it's not. Doesn't actually hit. So that is a function as well. This last one here, yes, this is a function. But the vertical line test is a quick and easy way to tell if something is a function or not. Make that font nice and big so you can read it there. Yes, that is going to be a function in that one. Okay? All right.